Welcome back, everyone. Now let's continue and proceed with an introduction to SIP. Charles, can you summarize for us what we'll be learning in this module?
Sure. What we'll be looking at is really the protocols and the messaging that happens within a simple voice application or voice call. Nothing really super detailed. We can't go into all of the possible options, but it would be the part that talks about, okay, what are the basic signaling for SIP? What are the basic signaling for managing the session and the actual transport protocols?
Okay, that sounds very good to learn about all those protocols. So before you get into the protocols, can you go into what is voice over IP and what it looks like?
Voice over IP is a protocol where we have signaling protocols. That's signaling protocol is what we call SIP. So here we have signaling protocols. I may have a SIP server involved to authenticate, and I'll have SIP communication between the subscriber and the server, ultimately to establish a communication path of signaling between two subscribers. Once we set that up, we're going to establish a bearer, which is going to carry the actual voice, but it doesn't go through the server. It goes between two endpoints.
I see the SIP, but I don't see real-time transfer protocol on this slide. Is this something that's part of this?
That's a good question. The protocol for real-time protocol is what will transport this voice bearer.
Now I guess you're going to tell us a little bit more about SIP.
Sure. Well, let's look at SIP. So we're going to look at just a couple things. We'll look at a quick overview of the basics of SIP. It will be SIP of actually the protocols that are involved. So first of all, when we do our layering, we have the data link layer. We have layer 1, which is physical layer. In this case, it would be LTE over the air. Otherwise, it's like Ethernet or ATM or some other layer 1. And layer 2. So both this really is layer 1 and layer 2 that we will be swapping out as we move through the system. From layer 3 above and above, that is going to be the actual protocols that we're dealing with. Layer 3 would be IP. Layer 4 is handling, we have two different transport protocols that we can use. One's called transmission control protocol and one's called user datagram protocol. We use an address called a port in those protocols. And the port number that we typically use for SIP signaling is called 5060. So it's 5060 is the port number. And whether we're using UDP as our transport protocol or TCP as our transport protocol, we will use port number 5060 typically. Now that is a configurable option that you would have to put in your server, but don't worry about going into the configuration of the server. We're not going there. We'll just use 5060 as our port number. Now above that is our session initiation protocol. Now we're using version 2 of the session initiation protocol, and that's described in the IETF, or Internet Engineering Task Force's set of standards called Request for Comment, or RFC. And the number for our RFC that describes SIP version 2 is RFC 3261. This is going to contain protocols that deal with session initiation protocol and something we'll also look at called the session descriptor protocol, or SDP. Now, there is another protocol that we're going to be dealing with in this module more so. It's the voice protocol. Again, data link layer and IP are going to be the same, but notice we only have UDP involved. So we're only utilizing a UDP or a user datagram protocol for our transport of voice. Now we'll have port numbers that are associated with each direction of that transport, and we'll see that later on when we get into the voice over the real-time protocol packets. Above that, I'm going to have a real-time protocol header. The real-time protocol header is going to define what is contained in the voice packet or in the packet of real-time packet. So it'll define whether it's audio-visual, something called the audio-visual profile, or also known as AVP. Don't confuse AVP with what we have in diameter, which is attribute value pair. We don't. This is an audio-visual profile. And we'll have timestamps and other things that are in the RTP header. We'll talk about that a little bit later in this presentation. We have the voice packet, and the voice packet is tied to the coder decoder, which will affect our compression of our audio, or if we're using features like silent suppression, bundling, and interleaving, all of that's going to be inside this voice packet, but it will be defined by the RTP packet.
Can you tell us a little bit more about SIP?
Let's start with how we identify the endpoints of SIP. This is called a SIP Uniform Resource Identifier, or a URI. Now, the way we identify it, it looks an awful lot like an email name. The difference is we add SIP : in front of the email name. So SIP : ken.c@voip.net is an example, or SIP : johnm@nokia.com. We also can identify a host. This would be a server. So something like SIP : server1.itsp.net. Okay, so that's one example of a server. Notice that we can also do it with a telephone number. So SIP : 412-339-1882 at sprint.net could be a valid Sprint device. The other option is we can also use an IP address. So SIP : Mary S at an IP address works as an example URI. Now, most of the time we're going to be using words, not IP addresses. We might use phone numbers because this is the way we could call a phone that is not in our network. This is what would force the server, as we saw in a previous module, to use a number lookup method called enum, or inum, is depending on where you're looking. So I could use any one of those, but I try to use something that is user-friendly. So it speaks English. All I have to do is add the SIP : in front of it.
Okay, when you say that you try to use, what does that mean?
Well, when we set up a system, we try to make it as user-friendly as possible. So let's look at a little bit more on the SIP. So we'll go on to the next part. Now we're going to have to define some terms here. So the term that we're going to look at principally is a term called method. In a method, that is a device, or that is a mechanism that defines what we're doing within SIP. So we'll see a little bit more about method in a second. So we're going to have a request line. So it'll be a method of some kind. So the word method will be replaced with the type of method we're using. And we're going to use request URI. So we're going to send where we're sending it to. And then we use the protocol that we're using. So it's, in this case, it's SIP 2.0. Inside the message, we're going to have a set of SIP headers. Now, there's a whole bunch of headers that we could have. And within those headers, after the headers, we're going to have the last little bit here. We could have a message body that may or may not be present depending on where we are in the signaling process. So if I'm responding to something, I don't necessarily have a message body. All right, so we move on a little bit. Let's look at the methods real quickly. So for example, the basic methods that we have, which are defined again in that request for comment 3261, are the invite, which is what it sets us up for a call, the acknowledgement, which confirms the invite, the bye, as in goodbye, the cancel, if we're in the middle of, if I have to make any changes, and then probably the one we need to talk about first would be register, because we have to register with the server somehow, or else we won't be able to do it. Now, there's a whole bunch more that are set up. So these are called extended SIP messages. These are defined in a different set of RFCs. We've defined which RFCs are there. We won't get into those in this because that's getting to super advanced SIP messaging, and we are not asking you to become SIP experts at the end of this module or this part. So let's look at the SIP response. Okay, so we send a message, we get a response back. In this response, we're going to have a SIP. We're going to tell what kind of protocol we're using, so SIP 2.0. Then we'll have a number, the type of response we're giving. And then we'll have a text. We'll again have the SIP headers, and we may or may not have body present, some kind of message body present in it. Looking at the numbers, what do the numbers mean? The numbers, typical numbers, are broken into a series of 100 codes. So 100 code, 200 code, 300 code, 400, so on. And some of them are going to be used for establishing the call or setting something up. So this type, for example, the 100 are provisional. That means we have not yet established the call. We're in progress. And then the 200 would be the success. The 300 handles redirection and so on. Looking at some of the typical responses that we have the 100, I'm trying to establish the communication. 180 means I have established communication with the destination, and that destination has informed me that it is making the ringtone sound, which then tells my endpoint to make it sound like it's ringing in the phone. Then I'll have the 183 session in progress. So anything going on in session in progress. So we're still trying to establish the call at this point. And then the 200 OK means I have completed it. That means I answered the phone. We have now set up a call. And we have a few others that are in place for the SIP messaging.
This is interesting. Can you remind me again where that response code was in the previous slide?
I'll go back. So that response code is found in those hashtag at the top of the response line.
So those hashtags are really just placeholder for us to know that there is going to be what you were just covering with the different types of response codes.
Yes. So let's go on to see what what we call a transaction. So when we look at a transaction, so this is our transaction, we're going to have that SIP code, and we're going to have that provisional. We're in the middle of a provisional transaction. We'll start a transaction, and we will end the transaction. So we start a transaction, say, with 22. It's a sequence number. So we'll have a sequence number that will identify a transaction. And we'll start the subscribe, and then we'll get a response back. It was 22 accepted, or 202 accepted. So this is that response code we just saw. And this would have been a subscribe 100 being sent to the SIP server. The 202 means I accepted it, but notice that both of them have the same C sequence. So that's called the transaction sequence. And that is how we manage the transactions. We identify where I am in the process using that C sequence. Now we're going to have a whole lot more identifiers a little later on. We move on to what happens if I send a SIP request and I don't get a SIP response. There's a timer that will be built into the client. Typically, we set it at 500 milliseconds. That may be adjustable, where we adjust, where we say we send it, and if I do not receive it within half a second, I do not receive a SIP response within half a second, then I will typically resend it until I get a response. Now, there will be timeouts for the whole call time. Again, all configurable by your network administrator. All right, so looking at it a little bit more, let's move on to the SIP headers. So SIP headers are what will identify the actual call. So the transaction was the C sequence. As we can see, that is one of the items in the header. The C sequence is an item in the header, transactions. Now we're going to identify what we call dialogues and calls. This is all within the SIP header. So looking at the dialogue, a dialogue is set by or is identified by something called a tag. So we establish a tag, but it's not just the tag, it's the from the URI plus the tag that identifies this endpoint of the dialogue, and the URI plus the tag that identifies the endpoint of the tag. And we also have a different identifier called the call ID. Now, this call ID, along with the tags, is what will identify the subscriber call in the conversation. Now, the dialogue just means, okay, we're having a conversation. Just like this is a module, we are having a conversation in this module. That would be identified by the host and tag, and the trainer and a tag, and the call ID. So this is the identity within that call. Now that's important as we move to the next point, which is when we have more than one subscriber or server involved in the call. So we have a call ID and we have tags for each of the endpoints. So this is like a 3 call. So subscriber 1 talks to the application server. Each one will have a tag for that dialogue. And then the server will have 2 tags. The other tag will be used for subscriber 2, which will have its own tag.
Charles, can you please explain when does the application server endpoint get involved typically?
That's a great question, because typically when we establish a call, the subscriber does not know the location of the other subscriber. So it establishes a dialogue with the server, and then the server finds the other subscriber. And that's when we would have this scenario. So we are using the server kind of as a proxy on behalf of the subscriber, because subscriber 1 can't find subscriber 2 directly.
Why can't they?
Because we don't know what the IP address is. We know the phone number if we have to look it up. Sometimes, too, we have to know what services we're able to use and not use.
So would this be like in a case of text messaging? I'm getting off topic here, but when you say application, would this be if both users are allowed to do text messaging? Would that be part of that?
That could very well be a part of it. And text messaging is not that far off topic. It's a great question.
I kind of getting the understanding about the header of SIP. Do you think you can tell us more about the message body?
Yeah, absolutely. Because what we do is we'll have the header that identifies the call. We're going to get into the message body and something called the session description. Okay, so the session description is what we are using to describe the actual voice session. So this is the negotiation to figure out, okay, what are we going to do? How are we going to talk? Are we going to talk English? Are we going to talk German? Are we going to talk French? Are we going to talk Spanish? Are we going to talk, pick your language? You know, that kind of thing. So we're establishing, okay, what is the protocol that we are going to use to communicate? Now, all of that is using a protocol called session descriptor protocol. Inside, this is in the message body of SIP. Those are defined in RFCs 4566 and RFC 3264. So it is carried in the message body, and we have a couple models that we'll use. We're only going to use the central one. So the first one is SDP announcement. This is what we're using. It's like broadcast. We use that in things like streaming. So streaming of games, of football game or cricket match or tennis match, something along that line. When we're streaming, we would use the SDP announcement format. Typically, we use the offer answer when we're using telephony. But there is also the option of using declaration offer and answer where I declare this is what I'm going to use. The other one, the response is from the second endpoint is this is what I'd like to offer you. And the answer is, okay, this is what we'll use. So, hey, this is what I can do. So that's the whole process that we'll use for session descriptor. So moving on. So here's what happens in our call. In the invite, we send that SDP offer. So this is the body of the invite SIP message. Inside there, we'll have the original IP address. That's the IP address of the subscriber. There will be the types of media. There will be encoding support. What kind of encoders will I support in that media? And I'm going to define a UDP port number to identify my end of the conversation so you know where to listen. So if you want to think about it, it is what channel am I going to be on? What frequency are we going to be on to listen to that on when it comes from user 1? User 2 answers in the final message or this 200 OK message. And in that message, I will also tell what is its IP address. So this origin IP address is the subscriber. What kind of media are we selecting? Or what kind of media types are we doing? Are we doing audio? Are we doing visual, video? And what coders or decoders or encoders am I using? And what is the port number or port numbers, depending on if I'm using multiple streams like video and audio? What number of port am I going to use when subscriber 2 is sending the audio? Once I've completed that, there's an acknowledgement saying, okay, I have received this and I acknowledge what that value is. So let's look at an SDP header. An SDP header, so this is inside the SDP. First of all, you'll notice that there's these VOSCTMBA little number names or whatever that looks like it's some kind of code. Well, the code actually is V is for version. V, and you may see an equal sign or you may see a colon, depending on how you capture it. But what it is the version is equal to what SDP version. Now, typically that version is 0. We also have the origin. Okay, so here is the IP address of the origin, of the originator. The S is the subject. If we were using subject of some kind, So if we needed to put a header, a subject header for our texts, like you were asking about earlier, here's where I would put my text. And the C is the contact. So what is my IP address when you send something back to me? So this is where I'm coming from. This is where you can send something to me. And then we have when did we start and when did we end? Except we haven't started anything yet in this particular example. Okay, that takes care of what we call session description. But now we have to get into media description. Now, in this particular example, we're using two types. We're using an audio portion as defined by the M, or media. M is media. And then I have a set. Now, I'll describe that hopefully in the next slide. We'll look at the audio, so it's audio, and then we're going to have a port number, we're going to have the type, and then we're going to have some audio visual profiles. Then we'll have some more descriptions that are going to describe these profiles down here. That's the A, so that's the attributes of that profile. So you can see 18 is here and 3 is there. I also could have a second media. This is why I may have multiple ports, because this is audio and this one is video. And it says, okay, here's the UDP port number that we'll be using, and here are the values. Now, that isn't 31. Well, that might be 31. That is 31 because it's defined in the attribute pair here. But I may have multiple lists of different kinds of media so that the other endpoint can say, okay, I only speak English and Spanish, and you're offering me English and German. Let's agree on English. Now we'll look at that in the next slide. So in this slide, we're looking at just the M line in the profile. So we're looking only at this line here. The M, that means the media type. I'm going to define, is it audio, is it video, or is it some kind of application like World of Warcraft gaming? That would be an application. So we define the type of media that we're using. We define the UDP port because we're not using TCP. We don't have time for retransmissions. We're going to use the transport type. In this case, it is the RTP, real-time protocol, and the audiovisual profiles. So we're going to use audiovisual profiles to define it. And then we're going to have a format list. This is the format of audiovisual profiles. And it is in order, as in the first audiovisual profile is the preferred, the second audiovisual profile is the second preferred. So if we can't do one, we do 2, 3, 4, however many are in the list. Let's look at the example. So let's look at audiovisual profiles for in this example. So the media is audio. I'm using port 8498 UDP. We're using real-time protocol with attribute or with audiovisual profiles, and the audiovisual profiles are 97, 0, and 18. Now, 97 is first on the list. We will prefer 97. Notice in the chart, that is enhanced variable rate codec for audio, typically used in the CDMA 2000 series cellular networks. So a RTP map. So now we're going to go ahead and define this. We're defining what the profile is. 97 is EVRC 8,000 samples a second. 0 is defined in the next row. So I define an A for each one of my profiles. and that would be 0 is pulse code modulation mu law 8,000 times a second. And then the last one, 18, is G729, 8,000 samples per second. Or that's how we define like the audio.
You're using a term I haven't heard before, MULA. Could you please tell me what that is?
In the original telephony systems, we had two different ways of encoding audio that was sampled. So the voltage value of audio was sampled, and there were two different ways to do it. There was A law here, so that would be 8 PCM A, and PCM mu. So it uses mu law or A law. Now, what is that? It just means that in the way that we code the value, we're going to use a slightly different method of, actually, it's a slightly different logarithm. So mu law uses logarithm base 10 for encoding the audio into a sample, single sample. A law uses the natural logarithm as the encoding logarithm for the sample. Again, it's just a difference of how we do it, and they are slightly compatible, or they are compatible, but they cause some interesting little quirks if you decode a packet with A law when it was encoded with mu law. It just makes it sound a little bit different. This is typically used, mu law is typically used in the United States, Canada, and Japan. A law is used everywhere else in the world, including Japan.
The other day we were talking offline, and I thought you gave me a good example of the difference between media and medium. Can you remind me how you explained that to me?
Okay, so we use a term media here. We talk about the media. So actually, I'm going to move to the next slide because then I can kind of go on to the next and continue. So we talk about video media. When we talk about media, if we think about it in English, we talk about the media being the BBC, the CNN, the New York Times, the whatever, some kind of news agency, for example. So we call them the media, but they have various medium over which they will transmit their data. So in this case, the medium for CNN could be television, could be newspaper, could be radio, it could be the internet. So those are medium in our network, or that's how we do it. So we look at media as the people who are sending it, and then the medium would be the content within the media or how they deliver that media. Okay, so let's look at the next example. So we're looking at a different media. In this case, we're looking at the video media. Again, we have the UDP port, and then we know it's the RTP and it's the audiovisual profile. Now, there are two of them. There's a 31 and a 33. The first in line is going to be the highest priority. The second in line is the second in priority. So if I can't negotiate and you can't handle the first priority, then you move to the second priority one. And if you can't handle that, then you have an error. And there is a actual error that is used to send back saying, I can't support that media. All right, so in this particular one, video, which is usually pretty heavy from the standpoint of the network, a lot of data, because video has a lot to transmit. So we limit our video here. So the application server limits the video. So this is called the application specific flow. This is the speed that it allows. It allows 128 kilobits per second. So this value will be in kilobits per second, and it's defined by the bearer, the B. So that's the size that we can use. Now, again, we get down to the A. Now we're defining the attribute. So here, number 31 is H261. Now, H261, looking at our table, that means we're doing N times 64 kilobits per second video encoding of some kind. The other one, 33, is MP2T or MP2T, which is MPEG-2 transport, and it's audio and video capable. Okay, so whichever one we end up using is defined in the answer for what we're going to look at.
The attributes are looking very similar to the audio. Are they the same?
The answer is yes, they are. The difference is in video, we also assign a speed so that we limit how much throughput is going through. Whereas the audio, it's actually limited by the actual type of codec that it uses. So in video, we add a limit to how fast, how much we can use in data.
I see you have lowest to first priority. Can you remind me again what that's about?
If we remember, when we have a list of media types, so media, audiovisual profiles, so 31 and 33, the first in the list is going to be the one we prefer to use. So this is the most preferred, or has the highest priority in being chosen. The second would be the next priority. And this is a negotiation that will happen between both ends to determine, okay, what language are we speaking? So if you wanted to look at it this way, we're going to use audio, or we're going to use English and Spanish. Which would you prefer to use, English or Spanish? And then you would answer
English.
You would answer English. So that's what this is about. So I speak English, Spanish, and Portuguese. That would be my attribute. That would be my audiovisual profiles. I would define those. So one would be Spanish, one would be English, one would be Portuguese. And whichever order I put them in is I would prefer to speak English over Spanish over Portuguese in that order. And then you would choose. But if you are a Spanish speaker, then you would say, well, I really can't speak English. Let me choose Spanish. It's really, if you cannot, then we would choose the language. So if you cannot do this one, you move to the next.
It's really helpful going through the attributes in the message body. Do you think you show us how it works in an actual call?
When we go to the call, first of all, we can't do a call immediately. We have to register to see if we have the privileges. So we have to register with our SIP server, because our SIP server is going to be the one that actually handles the call. It handles establishing and finding the other subscriber and tells us what we can and can't do. So we send a registration request to our SIP server. Now our SIP server will then challenge us and say, prove to me who you are. So that way we can authenticate that the subscriber can use this service. At the end of that challenge handshake, the subscriber will, the SIP server will say, okay, you are authenticated, and send the SIP 200 okay. So this is the beginning of the C sequence. This is the end of. So this is the dialogue for registration. First thing you have to do is you have to register. Now, once we get into a registration and we start a call, in a call, the subscriber who initiates the call will send the SIP invite, including the SIP offer, saying, okay, I speak English, Spanish, and Portuguese. Which one would you prefer? Now, the SIP server sends back a message saying, okay, I got your message. I'm trying to locate the other subscriber. It performs whatever it needs to in function to find the subscriber so that it can send it an invite with the offer. So it forwards this message 1 here across on message 3 to the subscriber who's the target. Now, the target, once it receives it, will send back a trying to the server saying, okay, I got your offer, I'm going to try. It then will activate whatever functions are inside the subscriber client to say, okay, let's go ahead and generate rings. Do I have to have a special ringtone for this subscriber or whatever? If it's my friend or whatever it may be generating. But once it starts choosing to do that, it will send back a ringing saying, I am making the phone ring. The SIP server forwards that to the originating UE, or the originating subscriber. Once the subscriber answers, so someone picks up the phone or hits the green button to say answer, the 200 OK is sent, and in that message, we send the SDP answer. So we're now looking at the SDP session here. So the SDP offer came in the invite, now it comes in the answer. It goes back to the server, which then forwards it to the originating you subscriber. In that SIP answer, I'm going to tell you what my media type is. Once I get that SIP OK, we now have established our path because we have descriptions. We now know the IP addresses. We can look and talk subscriber to subscriber directly. But the SIP signaling itself will not go directly between subscribers. It will go from the subscriber to the server to the other subscriber. Now, once we've made the call, we've established the call, and we'll talk more about the voice part in a little bit, but we will then, to end the call, whoever ends it will send a buy. In this case, the originating subscriber ends it by sending a buy to the SIP server, and then the SIP server forwards it to the subscriber, and then the target subscriber, who then sends back a 200 OK to the SIP server and a back to the originating subscriber. So now we have torn down our call. So that's the end of a call. We tear down that real-time protocol.
Kind of try to relate to this. It doesn't really say bye. All we hear is click when we're on our cell phones. So we just hear that click and we know that it's over.
That's correct.
SIP server that is actually getting the buy, so to speak.
And it's the message. This is the method of the SIP. It's called buy. So the name of the SIP, this is the SIP message. And then again, this is the buy message that is forwarded. But it goes through that SIP server.
I know you mentioned earlier about the RTP header. Could you go over that for us?
Let's look at that. We've talked about this SIP part. Let's focus on the voice bearer path. So let's go on here. In the bearer path, when we look at our data is typically created in what we call encapsulation. So inside the data link header, we have an IP header. Now, an IP header, we have quality of service and we have IP addresses. So we have the IP address and something called the differentiated services code point, which sets quality of service. In the UDP header, I'm going to have a UDP port with source and destination. I'm going to have, so I know what application to direct it to. Then I have the RTP header, which is going to handle the payload type. Okay, so what kind of media am I taking? And then I'm going to have sequence numbers so that I can keep the sequence of the audio or video in the correct sequence. So things arrive at the right time. And I timestamp that sequence so that I know how much jitter I have. And inside the voice packet is going to be whatever the voice packet is. Is it single packet? Is it bundled? Is it interleaved? Whatever we happen to be doing that is defined by this payload type.
Charles?
Yes.
What does that mean, single packet, bundled, and interleaved?
It's just methods of the way that they take the voice samples and put them into the voice packet. So let's look at that IP. Let's look at the RTP header. Now, if you look at it in closely, you're going to have some flags at the beginning. You're going to have the payload type. You're going to have a type of payload. So is it a video? Is it audio? So that we will define the payload type. Then we'll have a sequence number, timestamps. What is the source synchronization? So what are we using to synchronize the source? And we're going to have some contributing identifier list or whatever that we can add. The total of the typical RTP header is 12 bytes. Then we get into the actual real-time packet. So looking at that RTP header, inside the header, here's the RTP, here's the sequence number, I'll have the timestamp, and then it's going to be a voice packet. Now, the period between the transmission of voice packets on a regular T1 or E1, the typical transmission was a single byte, and it was transmitted 1/8,000th of a second between our transmissions. In voice over IP, typically the frame time is 20 milliseconds. So if you'll notice, this is sequence 1, sequence 2, sequence 3. If they happen to arrive at the subscriber endpoint in out of order, then we'll know what sequence to put them in if we have time to restructure it into the appropriate order. Now, when we look at that, that's what we call jitter. So what we have is we transmit and we're going to have that frame time, but unfortunately the internet is not always consistent. Sometimes it waits and it delays depending on the path or which path which packet went in. We add something called a dejitter buffer inside our receiving subscriber, which will then receive them, eliminate the gaps so that when we actually take that packet and regenerate it into regular audio, we don't hear gaps in the audio like I just created with my own voice. So we actually make it a smooth flow of audio at the far end, and that's what the dejitter buffer does. So we may have the arrival pattern, so this is the time that it arrives, how much delay I have, and sometimes if we have too late a delay, we will actually discard any packets that didn't make it in time. And yes, that is going to cause a little bit of chop in the audio at times because we just lost however many milliseconds we had of audio in that packet. Could have been 20 milliseconds of audio typically. So that's really the whole thing on SIP. Very quick overview of the whole process of SIP.
Charles, this was a lot of information about SIP and about SDP and about RTP. I'm wondering if you can help by summarize it for us so that we can see it now that we've gone through all the details, all the headers, and all the call flows. If you can summarize the whole total module.
Great, I will. Let's go back to this particular slide. In this slide, we see that the subscriber makes the communication with the SIP via session initiation protocol to the SIP server. Remember, it had to register with the server. When it initiates a call, it registers. It had registered with the server. It now sends the invite. The server serves as a proxy to hand that invite to the destination. In this process, while this subscriber rings, we don't establish any traffic of audio until someone answers, and then we send messaging back to establish this flow of bearer, which is our RTP packets. So session initiation protocol handles the signaling, and the actual flow is our RTP packets, whether it be voice or video. or some other application that we are setting up. So for example, if we did online gaming, it would be there. So these are all the process that we have for our that's a summary of everything that we've talked about.
Charles, this really has helped me understand SIP, and I think it would be helpful to our students if you could tie this into voice over LTE.
Let me give you some call flow examples. So first of all, we're looking at a SIP invite. So subscriber A and subscriber B are my subscribers in the network. So subscriber A here, subscriber A and subscriber B in the network are going to perform a call. So first of all, subscriber A will send the SIP invite, and notice that it goes to that thing called the call serving call function. We talked about that a little bit when we talked in the first module. Then the call serving call function will talk to the telephony application server to determine what the subscriber can do. The telephony application server responds and says the subscriber is able to support this service utilizing and this particular additional call serving call function as the proxy, the serving for the call serving call function. We then reroute the trigger to the call serving call function. So a lot of this is happening way away from the subscribers. Now that once we've handled the setup of all of the termination for subscriber A and subscriber B, so the first set of was saying, can A do it? Then we said, well, can B do it? And once we get B, the call serving call function will respond to the B side to say, here is the SIP invite. So all of that was to find the subscriber. All right, so this is all session initiation protocol signaling that's happening between the various elements inside the IMS. Now let's go to another one. For the voice, that's the actual communication path. We do not have to go through any servers in the network. We are going point through the server or through the gateways to point back to the server. So that's our audio path. Now here's another example. Now we're making a call from subscriber A to the public switch telephone network. So subscriber A sends in the SIP invite. We authenticate what the subscriber can do. Then the CSCF sends a message to the interface to the public switch telephone network. The gateway, so it's the media gateway control function, and that will send it out over SS7 to the public switch telephone network. Well, and then the subscriber for audio will send it through to the media gateway. So now we're going through the media gateway out to the public switch telephone network. So the media gateway now transcodes from what we use over voice over LTE to what the public switch telephone network does. Now let's look at the SIP invite if we're doing an LTE VoIP call to something other than the public switch telephone network. Now in this case, we receive an invite from some SIP server somewhere else in the world. And then we move on. We go ahead and authenticate the subscriber. Again, can the subscriber be found? Who is the serving CSCF? Then that CSCF will send the invite on to server or to the client A. Now we need to look at the next one. Now we're doing a SIP. Our media is now established, and notice that it is not going through the media gateway. So the only reason we need the media gateway is for interfacing with a non-VoIP system, such as public switch telephone network or another technology such as GSM or UMTS voice calls, but even there, we may not have a lot. We may not use the media gateway, depending on the format of our system. All right, so looking at it quickly, our voice call for SMS works a little bit differently. So you asked about texting earlier. Well, guess what? It is one of the possible options. So in texting, we encapsulate, so we receive our SMS here at the SMS server, which then forwards it to the SMS gateway, which then forwards it to the IMS, also known as the CSCF, out through the gateway, out to the subscriber, over the data link to the subscriber. Okay, so it's going to be a SIP message that is going to carry the actual text message. Now, looking at it quickly, so let's look at those flows more directly. Subscriber B is sending a text message to the CSCF. So we're sending it as an application. The CSCF will go ahead and authenticate the subscriber. Can it handle the SIP message? Does it support it? We'll then forward it to the SMS server for delivery to the destination. And now, if I'm getting a termination, now it's coming back. Now I receive an SMS. The SMS sends an interrogation to the HLR, home location register, to determine where the subscriber is. Sends that, and then that subscriber sends it. Oh, that's the telephony server's that's responsible for the voice. Forwards it to the telephony server. We determine where we're setting it up. We send a SIP message containing the SMS to the call serving call function, which then forwards it to the subscriber through the data network. All right. So now if we're sending it, and then we acknowledge that with a 200 OK. So the 200 OK has to go to the other endpoint, in this case, the telephony application server. Now, the sort message server may also need an additional authentication because it's the gateway for voice, for text messaging. So that's the basics of what is happening in our network. That's the basics of delivering the various things. And notice that it is all flowing over the data portion of the SAE gateway. It does not flow through the signaling of the MME and the eNode B and the gateways. It is all flowing through from the gateway external network. It is still signaling, but it's flowing over the data network to the various subscribers. Does that help?
Charles, thank you for taking SIP and tying it back into the voice over LTE call flows. You went into the details of the SIP, now bringing it back to the actual voice over LTE basic call flows has pulled it through for me. So I thank you for going through that. And I'm sure the audience is really going to understand a lot better as well.